Artificial intelligence is a word we hear a lot about these days, whether it's in movies, books, video games, or the news. But do we know what this phrase really stands for? What type of device counts as AI? What is the threshold separating AIs from non-intelligent machines? Are all AIs the same? In this video, we'll try to find an answer for these questions. So how should we define artificial intelligence? There are actually multiple definitions for artificial intelligence. One of the earliest definitions was given by John McCarthy in 1956 and states that a computer program can be considered AI if it does something that we would normally think of as intelligent in humans. But this leads to another question, the definition of intelligence. Again, there is no consensus on the meaning of intelligence. Some believe intelligence comes from a divine source, while others see it as no different from any regular series of chemical reactions. However, for purposes related to computers and machines, intelligence is studied from a more practical and utilitarian perspective. From this viewpoint, some definitions for intelligence include a certain set of cognitive capacities that enable an individual to adapt and thrive in any given environment they find themselves in. The ability of an organism to solve new problems. The ability to understand complex ideas, to adapt effectively to the environment, to learn from experience, and to engage in various forms of reasoning, and to overcome obstacles by taking thought. Two notions most of these definitions for intelligence have in common is the capacity to solve problems and adaptability with the environment. Based on these definitions, and with practicality in mind, researchers in the field of computer science have come up with multiple definitions for machine intelligence. Examples are doing well at a broad range of tasks, any system that generates adaptive behavior to meet goals in a range of environments, the ability of a system to act appropriately in an uncertain environment, where appropriate action is that which increases the probability of success. But these definitions won't be very useful unless there is a proper way to measure intelligence in machines. That is why multiple tests have been developed for this purpose. The most famous of these tests is the Turing test. In the Turing test, a human judge has two separate text-based conversations with another human and with a computer. The judge, however, does not know which conversation partner is the human and which is the computer. If throughout the test, the judge is unable to differentiate between the human and the computer, then the computer would have passed the Turing test. Another test is the compression test. Similar to a closed test, the computer must guess words omitted from a passage of text. Many linguistic tests used for human children have also been proposed for measuring intelligence in machines. However, some of these tests, including the Turing test, have been criticized for being a test of humanness rather than intelligence, due to their emphasis on human linguistics. Therefore, a number of tests have been designed which take other capabilities into account as well. These include IBM's Joshua Blue project, which uses a broad range of linguistic, social, association, and learning tests. Hassan Masum proposed a test based on succeeding in tasks and games. And an approach named the psychometric AI states that for a machine to be considered artificially intelligent, it must excel at all established and validated tests of human intelligence. In any case, the development of artificial intelligence has always been driven by practical needs, and that is why the definitions and tests of artificial intelligence have been devised with the practical goals of the developers in mind. And in the end, it is our expectations and requirements which make us decide whether a machine is as intelligent as we want it to be.